In section 11.1, we take a look at the goodness of fit test, where we're trying to see if some observed frequency distribution fits a claimed distribution. Let's take a look at this example. It says, a police department released the numbers of calls for the different days of the week during the month of October, as shown in the table to the right. Well, there's no table to the right, it's actually below it. It says, use a 0.01 significance level to test the claim that the different days of the week have the same frequencies of police calls. What is the fundamental error with this analysis? So now, when we're determining the null and alternative hypothesis with the goodness of fit test, the null hypothesis is always that the observed frequency fits the claimed distribution. So here it says, test the claim that the different days of the week have the same frequencies of police calls. So let's go ahead and take a look at our options. So the police calls occur with all different frequencies. Police calls occur with the same frequency on the different days of the week. So that's our original claim. And now the alternative hypothesis is that the observed frequency does not fit the claimed distribution. So in order for the claim not to be true, is at least one of them would be different. At least one day has a different frequency of calls than the other days. Okay, let's go ahead and check our answer real quick. Okay. And now it's going to ask us for the chi-square test statistic. So let's go ahead and open this up in Statcrunch. Open in Statcrunch. Let's do a side-by-side view. Okay, and now in Statcrunch, we're going to go to Stat, Goodness of Fit, and Chi-Square Test. Now, where it says observed, this was the observed frequency. This was in the column that says frequency. So frequency. And since we're trying to test the claim that all the days have the same amount of police calls, instead of me adding up all these numbers and then dividing it by 7, I could just click here and put all cells in equal proportion, and that's going to do it for me. And I just go ahead and click on compute, and it gives me all the values that I need. So this was the observed frequency, and this is what would be expected if each day had the same amount of police calls, 206.7. So now let's go ahead and put our information. So our test statistic here, the chi-square, we have 27 so round to 3 decimal places, we have 27.339. Okay, now it's asking us for the p-value. P-value is given to us right there, 0.0001. Okay, and now let's just open this up so you can see it better. It says, what is the conclusion for the hypothesis test? Well, over here, we're using a 0.01 significance level, and our p-value is 0.0001. So since our p-value is less than or equal to the significance level, that means we reject the null hypothesis. So we're going to reject the null hypothesis, and since the null hypothesis was the original claim itself, we rejected it. That means that there is sufficient evidence to warrant rejection of the claim. Okay, and now it's asking what is the fundamental error with this analysis? Well, October has 31 days, and there's 7 days in a week. Well, if we divided 31 by 7, it gives us 4. So each day of the week will occur 4 times in that month, but there's still 3 left over, meaning 3 of those days is going to occur 5 times. So because October has 31 days, 3 of the days of the week occur more often than the other days of the week. So our answer choice would be B.